Permutations. NPR, the number of ways of arranging or objects from n distinct objects. In how many ways can the letters of the word Ireland be arranged? Taking them 3 at a time and no repetitions allowed. There are 7 choices for the first letter because there are 7 letters in the word Ireland. I-R-E-L-A-N-D. So there are 7 choices for the first letter. So this top row represents the letter, the bottom row represents the number of choices. So there are 7 choices for the first letter. There are 6 choices for the next letter. So there's 6 choices for the second letter. And 5 choices for the last letter. So 5 choices for the third letter. So we want to arrange the letters of the word Ireland. There are 7 letters in total in Ireland. And we want to take them 3 at a time with no repetitions. So the first letter we have a choice of 7. Then using one of those, it doesn't matter which one, we're left with 6 choices for the second. And then we've used 2 out of the 7, so we're left with 5 choices for the third. And 7 by 6 by 5 is 210 ways. We are, in fact, trying to arrange a population of 7, taking 3 at a time. In general, if you have a population of n items, and you want to arrange or of them in order, then the number of possible permutations or arrangements is called NPR and is defined as follows. So this is our formula, NPR, and this equals n factorial divided by n minus r factorial, where n is the total number of objects or items to choose from, and r is the total number of objects or items we have to arrange in order. There is a formula in our formula book that looks quite like this formula, but it's not the exact same, so it is best to just learn the formula off by heart. So here's an example. Let's say we have 7p3. So the number on the top left hand corner of the p represents the n. And remember, the n is the total number of objects or items to choose from. So the n goes into the numerator as a factorial. So that's 7 goes into the numerator with an exclamation mark stuck on. So it's 7 factorial. And the n also goes into the front of our bracket. So we've got 7 in front of the bracket. And then the 3 is in the bottom right corner of the p. And that is in place of the or. So it's going to be minus or. So it becomes minus 3. And the 7 minus 3, then we apply the factorial rule to it. So this becomes 7 factorial divided by 7 minus 3 factorial. 7 minus 3 is 4, so we've got 4 factorial on the bottom and 7 factorial on the top. So we've got 7 by 6 by 5 by 4 by 3 by 2 by 1 divided by 4 by 3 by 2 by 1, which will give us 7 by 6 by 5, because basically the 4s, the 3s, the 2s and the 1s all cancel out, which give us 210. But you could stick this straight into the calculator if you wanted. So 7pn, we can stick this straight into the calculator by pressing NPR button. So you'd press 7, then the NPR button, then 3 and equals, and 210 would come straight up on the screen. Or you could stick this straight into the calculator using the fraction button. How many different 4-digit numbers can be made using the digits 1, 2, 4, 6, 7 and 8 if no digit may be used more than once, so no digit can be repeated? How many of these 4-digit numbers are even, odd or greater than 7,000? So part 1, how many 4-digit numbers can be made using the digits 1, 2, 4, 6, 7 and 8 if no digit may be used more than once, so no digit can be repeated? So there are no restrictions. So it will be a 4-digit number. For our first digit, we have 6 numbers to choose from. So we have 1, 2, 3, 4, 5, 6 numbers to choose from for our first digit. It is important to realize that we will fill in our number of choices and not the actual number. That's very, very important. So we're filling in our number or amount of choices and not the actual number. For our second digit, we will have 5 numbers to choose from, and so on. So remember, we had 6 digits to choose from. It doesn't matter what the digits actually are, but we had 6 to choose from for the first number. Once we've used one of them, again, it doesn't matter which one, we'll only have 5 left for the second. Once we've used 2 of them, again, it doesn't matter which 2, we'll only have 4 left for the third. And once we've used 3 of them, we'll only have 3 left for the fourth. And 6 by 5 by 4 by 3 is 360. Alternatively, we could have used our 6p4 rule. So remember the N, which is on the top left of the letter, in this case the P, the N is the total number of objects or items we have to choose from. So we have 6 digits to choose from. So the 6 goes in the top left corner of the P. And then the OR represents the total number of objects or items we have to arrange in order. So we have a 4-digit number to create. So we have 4 digits that we need to fill in. So the 4 goes in the bottom right corner of the P. And putting this into the calculator gives us 360 as well. So how many of these 4-digit numbers are even? If the number must be even numbers are determined by their last digit being even. So of the numbers we have in the list, the even numbers are 2, 4, 6, and 8. So if we want to find out how many of these digits are even, then the last number has to be 2, 4, 6, or 8. So one example of a 4-digit number using these numbers that has an even number at the end is 4,876. So that's just one example. So the last digit must be even for the number to be even. The last digit must be even, therefore there are 4 choices for this last digit, 2, 4, 6, or 8. So the 4th digit, or the last digit, has 4 choices out of the 6 numbers that we were given. So there are 4 choices for the 4th number. Once this choice has been filled in, we can return to the first digit. For the first digit, we now have 5 numbers to choose from, because one number has already been used for the last digit. So remember, we have 6 digits to use. We've already used 1 for the last digit. So 6 minus 1 leaves us with 5 digits left for the first digit. Once we've used one of them, we then have 4 digits left for the second and 3 digits left for the third. So 5 multiplied by 4 multiplied by 3 multiplied by 4 is 240. So there are 240 4-digit numbers that are even. Part 3. How many of these 4-digit numbers are odd? So if the number must be odd, a total of 360 4-digit numbers can be made from the digits 1, 2, 4, 6, 7, and 8. So remember, we got this from part 1. We worked out that there were 360 4-digit numbers that we could use using 1, 2, 4, 6, 7, and 8 if there were no restrictions. So we got this from part 1. So a total of 360 different 4-digit numbers can be made from the digits 1, 2, 4, 6, 7, and 8 if there are no restrictions. And of these 4-digit numbers, 240 of them are even. So remember, we got this from part 2. We got 240 options where we have an even number. Therefore, the remaining numbers must be odd. So 360 minus 240 leaves us with 120. Alternatively, we could have represented our choices as 5 by 4 by 3 by 2 by 120. The 2 is the last digit. So if the number has to be odd, then the last digit must be odd. And in our list, we only have 1 and 7 that are odd. So we only have 2 options for the last number. And again, once we've used up a digit for the last number, that leaves us with 5 left for the first one, 4 left for the second one, and 3 left for the third one. And 5 by 4 by 3 by 2 is 120. So it doesn't matter which method you use, but there are 120 different options where we end up with an odd number. And part 4, how many of these 4-digit numbers are greater than 7,000? So remember, we're arranging a 4-digit number, and we can only use one of these numbers here. So, if the arrangements must be greater than 7,000, if the number is greater than 7,000, then its first digit must be a 7 or an 8. Because any other 4-digit number that starts with a 1, a 2, a 4, or a 6 is less than 7,000. So if this 4-digit number must be greater than 7,000, then its first digit must be a 7 or an 8. For the first digit, we therefore have 2 choices. So for the first out of our 4 digits, we have a choice of 2. For the next digit, we have 5 choices. One number has already been used, and so on. So we've already used one of the digits out of the 6 for the first one. So that leaves us with 5 digits for the second, 4 for the third, and 3 for the last one. And 2 by 5 by 4 by 3 is 120. If the question had said how many of these 4-digit numbers are less than 7,000, then we would have had to choose a number that was less than 7. So we would have been left with 1, 2, 4, and 6. So we would have had 4 options for the first, 5 for the second, 4 for the third, and 3 for the fourth, and we would have multiplied them out. And this would have been 4 by 5 by 4 by 3, which would have given us 240. Or a quicker way would have been to say, well, there's 360 ways I can arrange them in total with no restrictions, minus 120 ways for it being greater than 7,000, leaves me with 240 ways of it being less than 7,000.